So if you start, if you download VVV, the latest beta 35, you install it like it's written on the web page, then you open it, and then you should see a blank window like this. And then if you work with VL, it's a good practice to first save your patch in order to set some paths. So I'll click Save As. I think we have here folder examples.
And if you experience any problems, then feel free to ask somebody standing here around. We try to jump to you and help you.
So I've just saved this patch. So first I'll set up a little bit view of the data we will process. So here renderer, if you middle click on a layer input, you can generate a group. Now access 2D, there we go. So point 2D. So let's make a 2D vector. And the X position for better visualization, I give it a linear spread like this, and then so I make just like 7 points with a random Y position. Okay, so that's a setup. And now I'll create a VL node. And in order to do that, you double click and then hit V space. And if you have V space pressed in the node browser, you will only see nodes that have been patched in VL. And there are quite a few already, almost 120. And then if you want to start, we have 2 templates. One is the usual template I think you should use most of the time. And the other one is stateless, which has a little bit less features, but you don't always need all the features. And I'm going to take this one because I will later use it to show something. So then, in order to get the clone dialog, you press Control, click the mouse on the template, and then this dialog will open where you can give it a new name. Resample. And I call this 2D and no version. Or like VL or so. Okay. And now what we will do in the background, it takes the template VL document, renames it with the name you gave it, then saves it on disk. If we have a look, this resample patch, I just saved it here. That's the reason why I saved it. Now VV knows, okay, I have this patch path, and besides of this patch, VV now has created this VL folder, and in this VL folder, it has copied the template file, and it's now besides the patch.
Yeah. It's the same kind of thing which happens when you, for example, clone a dynamic C# plugin, same thing, or an effect.
Yeah, shaders, it always.
VL is just one other, so to say, language in VVV.
Yeah, if you tag template, you see a lot of templates, And you can clone them all in the same way, like either Control Enter or Control Click to open the cloning dialog. Yeah, so I have this node, and you see this little square icon here indicates that this is a node created in VL. And then to open it, you just right-click it, and then the VL editor should open, like this. So, and this little box here, this is the node definition for this VVV node here. So this is the application, and this is the definition of the node. And you see here the representation of this input pin. It just pipes the data through to the output pin. Output pin is here. Okay, but I will delete everything right now. Maybe not the comment here. So now you see there are no more pins. I just deleted them. So it's just compiled as you change something. And now I will patch the resample algorithm. I will not explain in detail what it does because I think you understand it anyway. But what I need for it is a loop. So in order to create a loop, you type just loop in the node browser. So everything you want to create is in the node browser, like input pins, output pins, stuff like that. And also language constructs like the loop. So here you click the loop. This loop has an iteration count. And this iteration count will be our resample count. And as you see, if you start a link and then double click, it will automatically create an input pin. And the name of the pin is already in edit mode. So if you just double click, then you can start edit it. And I call this the resample count. Oh yeah, no problem. To zoom in VL, it's just mouse wheel. So that's the resample count. We are going to resample. Then we make another input. This is the input spread. And here, in the end, we will interpolate between two values of the spread. So I'll make here get slice, spread, and another one, first and the second. And I already know that they will be consecutive, so I need to increment some index. Don't need this anymore. So input spread. And you see this, those are like this light gray or transparent indicates that those nodes are not yet compiled into they are there. But what's not clear for VL right now is what is the type of the spread. It knows already, okay, I've used the getSlice spread, so the input type here will be a spread, but it's not clear yet what kind of spread it will be. So it could be a spread of values, of colors, of whatever. So it's already generic, but VV doesn't understand generic pins. So it says, okay, I don't know what to do. And we have to define this type. And I can do this here by writing spread. And then, oh, this is like this. And float 32 is the default value type in VL.
I think you want to have a vector.
I want to have a 2D vector, right? This would be a one-dimensional, but we want to resample vector 2. Right. So, and this will also be the input for this one. So, and now it knows, okay, it's a spread of vector 2, and now in VVV, here we have this first input pin, this resample count. This will be the amount of output values we will generate. And then here it knows, okay, a spread of 2D vectors. No, it's not a pin.
Can you do an alt right click? I think the pin ordering is kind of messed up. No? Yeah.
Oh, yeah.
So it's not simple.
Yeah, input spread, it's this one. This has a bin size pin because of the spreading mechanism in VAV. And this is the resample count, which is just a number. So, and in the end we will lerp those two values. And there is a lerp for 2D vectors, which lerps between them. And then I will just patch the algorithm right now. Not going into detail. This will be the index. This will be the interpolation value. And then I will use the index of the loop. So this loop will, so everything that's in here in the loop will be executed as many times as the iteration count defines. And for every iteration of this loop, I want to output one value. And in order to do that, I'll start a connection on the lerp output. And then the loop will present you two options to click on the output border. And the first one, this little diamond here, is an accumulator. We will use that later in the connect all example. And the lower one is, we call it splicer. It generates an output spread, so a collection of values from a single value inside of the loop. So here, for every iteration, we will generate a vector 2, and the output, if you connect it here, will be a spread of vectors. So for each iteration, there's one output vector created. And this will be the output, just call it output. Those are the resampled values. So it should be here, the pin, yeah. Okay, and now I have to multiply the index with some ratio between the input and output spread. Can do it like this. Index. Oh, what does it say?
Because it's int.
Okay. Okay. Here I need the division between the count of the input spread and the resample spread, and this should also be float. Now it should work. Yep. Okay. And this should already do something, so let's try it. We'll input the 7 points here, those ones. And then we will also draw them. Let's make them the original points red. And copy this. And make it white. One more put here. Okay. And here we should already have 64 values, so it already does something like this. Okay, it's already resampling. And if I now increase the amount, you see there's an interpolation between the first and the last one. This is due to some index vs count thing. What I have to do is to decrement this one and this one, and you see this one. So now it's correct. So now you can here adjust the count, and it resamples the value into a bigger. Okay, so this is basically how it works to generate or compile your own VV nodes. You patch here, and as you patch, the node here will be compiled and integrated into VV. So there's one interesting feature I want to show you with this example before we get into the next example, and it's the generic nature of VL. This whole patch here can work for a lot of types, because the only function that is specific to vector 2 is this lerp here. Because the get_slice_spread can work with any type. You can have any kind of data in this spread. The only limitation here we have is VV, because VV doesn't understand generics. So I'll make a copy of this one. And I call this Resample, just like this. I disable this button, which tells it, okay, it can be generic. Then I remove this type annotation. And now you see the input here got empty, like it doesn't know what type it will be, but it knows, okay, I can accept whatever type. And here as well, it will be spread of the same type as the input spread, and I will apply some lerp function. And now every type that has a lerp function will work with this resample. So there is a lerp for color, so this will also work for colors, and I will show it quickly. So instead of calling this patch here, we can now, this now just defines a VL node. I can now use the resample VL node here. Oh, the naming isn't very good. So okay, so now I'm calling this generic definition, and it automatically creates a 2D version of this code. And now I make a second one, this one, and I call this color. I remove here the version, it's not important. Oh, it doesn't work. No, because it's the same name as this one. And now the only thing I have to do here is, instead of vector 2, oops, so now I have a second node in VV, Resample, 2D color. Is it this one?
Yeah.
And if I now generate like 7 colors, oh, not lightness. Here. Hue. So now you see those 7 colors, and now we can resample those colors as well with the same count. Put this here, and if we enable it, you see that the colors get resampled as well. So this is a very powerful feature, because you just write a patch one time, like this, and now every type that can lerp will be able to work with this node. And the reason I have to make 2 instances here for 2D vectors and for colors is the reason that VV doesn't understand generics. But in VL itself, we only have to use this node, and it will just work every time. So you can resample 3D vectors with it, you can resample float values with it. And if you make your own, like a 5-dimensional box, and you define a lerp for your box, you can also use this algorithm with your own box. So yeah, this was the first example to just give you an idea how you set stuff up and how VL works.